Hello, good morning, good afternoon, good evening, everybody. Welcome to our intern SUSE webinar session, Team Up on the Data Center of the Future. My name is Jan Krüger from Intel. I'm on the SAP account team, the technology lead, as well as the SUSE technical lead at Intel. And I'm joined here with my friend and colleague, Christian Halsing.
Also, welcome from my side. As Jan said, my name is Christian Holsing. I cover in SUSE the product management aspects for all our initiatives with SAP and, of course, Intel, SAP related.
Thank you, Christian. So given only half an hour we have, so let's dive right into it. So Intel and at Intel, we believe that it's all about data. And it's all about your data. So the incoming flood of data and the requirement to process them, to interpret them, to analyze them is driving everything we design and build at Intel. We break through the barrier of ever increasing complexity to bring value to you and your customers. We are familiar with the story around how much data is being created, but the real challenges and opportunities are much broader. So it's all about the data we store and process and finding the right relationships between them. And when we talk about data, we understand all sorts of data, whether these are structured data or unstructured data, which is driving the work then of our data scientists, which are trying to get meaningful information out of those data lakes. There has been a growing importance of data location as well, which is driving the ability to process the data. The biggest challenge in our view is what's the time and what's the data's time to value? So how fast can you build solutions to analyze the data and make recommendation out of that data? Where latency is important, as well as the accuracy and the truth of the data when it comes to data governance. So all of those will drive the requirements for compute performance, network performance, and computation. In order to unleash that potential of our data, Intel is providing a very strong portfolio of components required in such data center. We are focusing at Intel on optimizations for those components in software as well. And it had been a journey for us to build such a portfolio with differentiated and leadership products, which are driving and supporting the requirements of our customers. And those solutions start with moving data even faster than ever before with our Intel Ethernet and Silicon Photonics products. To store more data than ever with our Intel Optane persistent memory and Intel SSDs products. And our main focus on process everything, everywhere, and anytime with our portfolio about processors from our Xeon product line, as well as our FPGA products from the Agilix product line, and our XE product, which is going to launch later this year on our discrete graphics. And beyond that, we have many more products in those different categories. The optimizations we are looking for when it comes to software and system level is something we do with our partners like SUSE to make sure that all the greatness we are putting in our hardware components making their way through the operating system to the developers so that they can build software and tools around those capabilities to process all the data, transport all the data, and get insights into the data with AI and machine learning tools. So how will actually the data center of the future then look like with the evolution to a microservices-based environment? So to really realize this potential of the data center of the future, intelligent architecture is required, where large-scaled distributed heterogeneous compute environment work together and is connected seamlessly and in near real time. All of this will be enabled with software frameworks, particularly designed for the components underneath to make sure that services and solutions on top of it can use all the optimized instructions and functions in software. The intelligent data center architecture features the CPUs on one hand side, which are delivering an increased level of performance across all these various real-world workloads, and boost microservices performance through increased orchestration capabilities. It will leverage a wide range of XPUs to optimize performance of more specialized workloads. Memory will have the capability to be shared within and between nodes. And it will leverage infrastructure processing units, or IPUs, that intelligently manage system-level resources. Those components will then be connected via high bandwidth, low latency optical networking with the likes of silicon photonics that deliver the power efficient connectivity. This architecture requires software optimizations across all those components through a vertically integrated software stack, which we're working on with our partners like SUSE to unlock that additional performance in the platform in the entire stack. So through the operating system with drivers and libraries, on the orchestration layer or virtualization, so that software developers at the end of the day can leverage those components. So by tuning in on the on the CPU side in the first place, Intel is currently at the Cooper Lake and Cascade Lake timeframe as been seen here. And we've just launched 2 weeks ago our latest third generation Xeon processors, which are starting that journey to an intelligent and data center of the future by providing new technologies like PCI Gen 4, more memory channels, optimized crypto acceleration, and an overall performance improvement of 38%. By end of this year, we are planning to launch our next generation Xeon processor, Sapphire Rapids, which is going to introduce all the necessary technologies for the data center of the futures, like DDR5 memory, PCIe Gen 5 memory, PCIe Gen 5 as well, and additional accelerators for machine learning and AI. So the advancements are going to continue in the next generation processors as well, given the growing demand of processing your data at lightning speed. So in particular, what we wanted to share with you is also a view into one of our very compute demanding workloads. And at Intel, our drive is to allow and enable SAP to be at its best by providing the underlying technologies enabled through SUSE operating system, which are then powering your intelligent enterprise. So how do we do this, and what are the benefits out of it for you? We are solving customer challenges through being better together, right? The 1+1 in this case is not just 2, it is more than that, given the long-standing relationship between Intel and SAP. We are jointly innovating to enable in-memory databases so that you can process and store more data than ever before. Intel has been providing various technologies as part of its Xeon processor family, which are enabling customers to get faster insights. Intel's gen-over-gen performance grows significantly, which enabled SAP HANA to process much more data. In example, and between our first and third generation Xeon processors, we are delivering an increased performance, which enables SAP HANA to execute 20% more queries per hour on that new generation silicon. Those benchmarks are published, and you can look for yourself at the SAP benchmark directory. As you know, SAP is a highly regulated environment, and SAP certified appliances, TDI systems, or infrastructure as a service instances delivering the assurance you need for your enterprise. Intel is powering the largest SAP ecosystem and enables you to find the right hardware platform or instance for your workload. The certified instances are available on-premise through our valued OEM partners or through the cloud through our valued CSP partners. This enables your enterprise to build an on-prem and cloud or an hybrid architecture without being locked into a particular infrastructure. Given you can find everywhere an SAP certified Intel-based appliance or instances. That allows you to be faster and more nimble and be able to extend your business easily to the cloud or use the benefits of a hybrid architecture. Additionally, Intel and SAP enabled Intel Optane Persistent Memory and SAP HANA. Intel Optane Persistent Memory is a new tier of memory, allowing you to build larger systems than ever before. Generally, you can get twice as much memory for the same price over a DRAM-only system. And as an example, with our latest generation Xeon processor, you can attach up to 6 terabytes per socket. So you can build very large systems running SAP HANA. SAP HANA uses Optane Persistent Memory as hot memory tier. So in case you have large OLAP scenarios where usually a lot of data is being stored hot, you can leverage the advantages of Optane Persistent Memory in storing as much hot data as you need to accelerate your insights of your OLAP-based workloads. It also allows you to simplify and consolidate your landscape. In the past, you had to use more servers to address the memory demand for your SAP landscape. With Optane Persistent Memory, you can build high-density servers where you can consolidate more workloads onto a single system. And given that you can attach up to those, in example, 6 terabytes per socket with Optane Persistent Memory, you can build very large systems. As an example, combining the QA system with other workloads or having multiple SAP instances previously running on individual servers consolidated into a single server. So what's the journey on deciding what hardware is best for you? So at Intel, we are proposing a 7 stages approach or 7 phases approach. In the first phase, you usually decide whether you are on-prem or on cloud or on a hybrid model from your deployment point of view. Intel powers, as mentioned before, the largest SAP ecosystem, so you will find at all the SAP partners the right platform from you, ranging from very small system to very large system up to 24 terabytes in a scale-up configuration. The second phase in the journey is really the sizing of your hardware components. That's an important step in the process as it really drives the decision. Using SAP sizing tools will guide you on the decision. Intel has supported SAP in looking at the right measurements and deciding on what those measurements result to in terms of hardware selection. If you have further questions, please work with the SAP expert sizing team or landscape optimization experts, which will also help you to build an SAP system designed or optimized for your particular hardware choice. So in case of Optane Persistent Memory, as an example, you can optimize your SAP landscape towards using the available memory in the best meaningful way. Based on the sizing, look out for the latest generation products from Intel available at the on-prem or in the cloud or in a hybrid scenario, because that gives you the assurance that you get the best performance and resiliency out of those systems. Also look out for SUSE / for SAP as an option to run on those infrastructures, as we've been working with SUSE together to enable all the necessary components and technologies for SAP HANA to run at its best. In case of going for virtual appliance or instances in the cloud, please look out for Optane-enabled instances as well, since they are already available at the hyperscalers, and those are providing you usually a TCO optimization opportunity, as you can consolidate existing workloads to a single system using Optane Persistent Memory. In general, as I said before, Optane provides twice as much the capacity for a similar price than a DRAM system. Next, you basically determine your cluster strategy, where you go for a scale up or scale out. SAP and Intel had been collaborating to enable the largest 24 terabyte scale-up system as well as the largest scale-out opportunity setups you have available on an on-prem scenario or on the cloud. At last, the decision of your HA strategy, which can also benefit from our Intel Xeon capabilities as well as from the obtained persistent memory. It's critical to ensure continuous operation. Christian will go further into this particular topic since Intel and SUSE had been actively working on improving the critical components for day one operations. Before I hand it over to Christian, just a quick outlook here and a quick recap as well. SUSE Linux Enterprise Edition enable a lot of capabilities at Intel third generations, which can the customers benefit from. As an example, for SAP in particular, Intel TSX technology is further optimized since its introduction, and the latest generation delivers even further performance than ever before. And as Hasso Plattner himself valued it as a dream in 2015, as we've been starting on this journey. I look forward, Intel and SUSE are focusing on enabling our customers to not just run workloads. It's about resiliency in the operations. So with that, I would like to hand it over to Christian.
So in general, to pick up from here, I would like to share a little bit the view how the technology that Intel is enabling actually make it into the distribution. So first of all, when you take a look at the right-hand side of the chart, basically, obviously, SUSE as the operating system is sitting in the middle. And our job is to take the innovation that Intel is providing both on the hardware and the software layer, integrate it into the operating system, test it, and get it to an enterprise-ready state so that it's available to the SAP customers. And Jan already touched on a couple of Intel features like TSX and AVX 512 that are really important here in the HANA space. And I assume most of you who are listening to us here are aware that HANA is in a memory database, which means that basically everything or the whole data set is loaded into memory, and that drives the high memory demand that Jan was referring to. And because it's all in memory and it's basically originally a database that has an analytics background, a lot of the accelerations in terms of vector operations, in terms of having very fast compute operations and analytics operations are critically important for a fast performance of HANA. So these features and the respective software components, as I said, we take into the SUSE Linux Enterprise server, we validate it, we integrate it with all the other components, and we also integrate it into the Linux kernel, obviously where applicable, that we ship as part of the product. And there's one thing that I just want to highlight from the work on SAP here, where basically with the latest Ice Lake and Cooper Lake processor generations that Jan was referring to, there were questions about which kernel they are available in and which service pack. And I think this was particular on Cooper Lake. Where basically we were looking at the 5X kernel stream where the new features are available. I mean, sure, the older service packs would run, but in general, you can assume that if Intel brings new features forward, that Intel develops them on the latest kernel stream, and that we, for most generations, will support them on that kernel version as well. Sometimes there are backports that we do, right? But in general, and that's why we took SAP as an example. It's a really interesting use case here, how we are collaborating together from an Intel, SAP, and SUSE perspective And let me just take you to into one example that we worked on for some time now, and Jan has touched on Optane a few times already here. So in general, from an SAP customer perspective, there are two aspects here that are really valuable for an SAP customer. Jan touched already on the ability to have more memory associated to a socket and a CPU with that. So that allows customers to build smaller systems or consolidate workloads on the same amount of sockets. Originally, when we looked into Optane memory, the starting use case was that Optane is persistent memory, which means that the data loaded into memory survives a reboot of the server. And I don't know if everyone here is familiar with the size of the HANA databases, but we're talking terabytes. And as you heard Jan saying before, there are use cases where customers have 24 terabytes, and we're seeing customers that even go beyond the 24 terabytes right now and have even larger databases. So remember, all these database data is in main memory. So you can assume there are very large machines here. And if you think about the fact that on a reboot, you would need to load the whole database from disk, that's just going to take a while. And right here, Optane persistent memory represents a huge value add as the reboot of the server, as one of our customer mentioned in our SAP advisory boards last week. They are able to cut down the reboot of a server from 3 hours and the restart of HANA from 3 hours to 30 minutes. So that's significant also in the aspect of the cluster, because that means you basically run on one cluster node in the HANA only for 30 minutes and not 3 hours. So that's a risk mitigation thing. But coming back to the more technical aspects on this, so we really collaborated amongst the three companies in the SAP labs in Germany, worked very closely with Intel and SAP engineers from a SUSE perspective to test Optane persistent memory on with the Intel CPUs on the Intel platform together with SAP, working on what packages would be needed for the SUSE Linux Enterprise server. And we're basically, from a SUSE perspective, the first Linux distribution in the SAP market to officially support and enable the use of Optane persistent memory for SAP customers. So this is one great example, and there are a few more, but we're really from a SUSE side in a good position here as SAP is developing SAP HANA on top of SUSE Linux Enterprise Server. And with that as customers, you can certainly benefit from this end-to-end collaboration between Intel, SAP, and SUSE, and can trust that there are thoroughly tested solutions in the market that are validated by SAP. Okay, good. So obviously this is a prime example looking a little bit in the rear mirror, but we're actively collaborating right now at new areas and new ideas that we want to bring forward. So you probably have noticed that in SLAS for SAP, we have added in SP2 the monitoring capabilities based on Prometheus and Grafana with the node exporter, with the pacemaker exporter, with the HANA and NetWeaver exporters. And right now we are starting to investigate the area to bring exporters that Intel provides on a hardware level into the solution. So, for example, Intel has the ability to monitor CPUs for features and DIMMs for DIMM failures. And if you put this in the context of HANA as an in-memory database, you obviously want to know early on that you're facing problems with your main memory and to initiate a failover of the cluster to replace the DIMMs at your speed and on your decision, instead of actually seeing a failure in consistency in HANA, and then you are ending up in an emergency mode. So enabling the technology is one thing, and then looking together with Intel and SAP where we want to take it, what further options we're having in terms of alerting an administrator early on, maybe integrating it with the HA stack. There are a couple of interesting opportunities. Speaking about HA here, as Jan said, there's also kind of a research going on right now to look into network metrics. Obviously, from a HA and pacemaker perspective, latency in the network is a big factor that customers sometimes struggle with in terms of configuring pacemaker failovers. And we're also looking in these aspects right now to basically see if we can take metrics that Intel is capturing on the hardware layer into the SUSE HA solution, and with that improve stability and strengthen the SAP operation on top of SUSE Linux Enterprise Server for SAP even further, right? So that's that aspect. There's also the aspect in the Kubernetes environment. We see the market moving over to containerized workloads. From a SUSE perspective, we provide a Kubernetes solution with the Rancher portfolio. SAP themselves is moving into this direction. Not only with data intelligence, there are also other areas that look into containerized workloads. But also here, the same applies that we've seen with for example, TSX, where there needs to be an enablement of the Kubernetes distribution, or there should be an enablement of the Kubernetes distribution to actually take advantage of the underlying features that Intel provides in silicon, and to be able to, for example, use encryption accelerators. That's one of the prime examples that Jan and I have discussed in the last few weeks, that instead of computing encryption via the CPU, why not take advantage of the extension that is on silicon, move that workload off the CPU and basically accelerate the workloads overall. So that's also an area that we're exploring right now and see how we can bring the innovation that Intel has created into a SUSE product, and with that to market. Good, and I think that gets us back to Jan.
Thank you, Christian. Very insightful. So to wrap it up, as I said at the beginning, it's all about data, and we are trying to enable you to develop applications or use applications like in the example with SAP HANA with best performance, and also making sure that all the technology we are implementing and providing through our products is properly enabled in the SUSE operating system, whether this is for a microservice-based architecture or a native architecture, or it's virtualized, whether this is on-premise or on the cloud or in a hybrid scenario. So with that said, I would like to thank you all for your participation and wish you a nice day. Thank you very much. Goodbye.